Hello students, this is Dr. Siva Nagaraju from IARE. Today we are going to see the definition terminology of module 1 in analog and digital communications course. Okay, so we know the meaning of terminology. Terminology is nothing but technical terms. So definitions and technical terms what are used in this module 1 of analog and digital communications course. Okay, so coming to the module 1. So module 1 which belongs to the amplitude modulation, and this module 1 is covered by the first course outcome, and course outcome first states that outline the basic concepts of communication system, need of modulation and fundamental elements to realize amplitude modulation systems. Okay, so this is the course outcome. Now we are going to see the definitions and terminology of this first module. Okay, let us start. First, definition of modulation. Define modulation or definition of modulation. Why? Because modulation is first for any communication. Why? For long distance communication, modulation is must and should. So first we know the definition of modulation. So modulation is the process in which the carrier signal is varied according to the instantaneous value of the message signal. Here we may call the message signal as the information carrying signal, information bearing signal, or baseband signal, or also called the modulating signal. Okay, for any modulation we must require two signals. One is message signal and another is a carrier signal. So we require these two signals. With these signals we are going to modulation. So modulation is the process in which the carrier signal is varied. So here what I am varying? Carrier signal. Carrier signal is varied according to the instantaneous value of the message signal. Here instantaneous means some amplitude. So the carrier signal is varying according to the amplitude of the message signal. So we have different varieties of modulations. Amplitude modulation, phase modulation, frequency modulation, like that. Why? Because here for any signal we are having three parameters. What that? One is the amplitude, frequency, phase, or time. What it may be, time or frequency. So three parameters are there. So out of these three parameters, we can change any one. The meaning is varied. So this is the modulation. Okay. Coming to the next one. Define baseband signal. Define baseband signal. Already we see in the modulation. So baseband signal in communication systems, the information carrying signal that is modulated onto a carrier for transmission. So in previous definition we have seen the modulation. Modulation means here some of the characteristics of the carrier signal is varied in accordance with the instantaneous value of the message signal. Or simply you can say another one. Here we are superimposing the message signal on the carrier signal. So that is also called modulation. What is it? Understanding way. But the technical way, the first one is the correct. Okay. So now what is baseband? Baseband is nothing but the message signal or information carrying signal or original frequency signal. Number of ways you can say. Okay. So define baseband signal. Another is a define carrier. Why? These two signals are very, very important for modulation. Okay. So define carrier. So the RF signal in a communication system that has the modulating signal superimposed on it without modulation, it is simple RF signal. So carrier signal is just a RF signal. doesn't having any information. It's just a carrier. Okay, it is just a carrier. Here, the message signal or baseband signal which having the information. So this carrier signal which carries that modulating signal or baseband signal. So these two signals are very, very important for modulation. Next, define modulation property. The property of the Fourier transform in which the Fourier transform of a modulating signal C of t power j omega naught t is equal to C of omega minus omega naught, where C omega is the Fourier transform of C of t. Okay. So this is definition of modulation property. And define pilot carrier. The high frequency signal which has certain phase, frequency, amplitude but contains no information is called a carrier signal, already discussed. It is a high frequency signal. Pilot carrier is a small carrier transmitted with a modulated signal from the transmitter. It provides synchronization at the receiver. So here the pilot which is useful for synchronization at the receiver. Why? Already we know that baseband signal is a low frequency signal, but carries a high frequency signal. So that's why we are superimposing the low frequency message signal on a high frequency carrier signal. That is modulation. So the modulation is done at the transmitter point. After modulation, we are transmitted the signal into the channel. So the signal travels in the channel and finally it reaches a destination called receiver. So the receiver which is going to extract the information from that signal. So here the pilot which is used or which is give necessary information of the transmit signal at the receiver. So it provides a synchronization at the receiver. Okay. I define transmission efficiency of AM wave. AM wave is the amplitude modulated wave. So the transmission efficiency of a AM wave is defined as the percentage of total power contributed by sidebands of the AM signal. So here AM signal we can call it as DSB full carrier. DSB full carrier. That means double sideband, two sidebands with full carrier, that is AM wave. Okay. Define FDMA or frequency division multiple access. So frequency division multiple access, a multiple access technique based on assigning each user a unique frequency band upon which transmission takes place. So this FDMA we can treat it as an analog version. So that's why here we added this one. Whereas TDMA is coming to the digital one. This is slots in time. Here it is used or it is assigned a separate frequency band to each user. Okay, so it is a multiple access technique. And what is the balanced modulator? Balanced modulator is a modulator in which the carrier and modulating signal are introduced so that the output contains the two sidebands without the carrier. So it is a modulator. Simply balanced modulator is a modulator. Define local oscillator. So local oscillator is an oscillator or a circuit that produces a periodic signal whose function used to be utilized in the demodulation of a received radio signal. The demodulation of a received radio signal. So local oscillator is a circuit which produces the signal or which generates a signal. Okay. defined ring modulator. So ring modulator is a product modulator used for DSB-SC generation. So what is DSB? Double sideband suppressor carrier. So the ring modulator is a modulator or a product modulator used for DSB-SC generation. So what it consists? It consists of 4 diodes connected in the form of a ring. So we can call as a ring modulator. Define envelope detector. Envelope detector, the optimum structure for detecting a modulated sinusoid with random phase in the presence of relative white Gaussian noise. So already we said that transmitter which is going to transmit the signal after modulation, the signal which enters into the channel, and in the channel the additive white Gaussian noise will add it to the signal. The signal is going to corrupted. So the corrupted means here some noise is added, some disturbance. Noise is nothing but which doesn't require signal. It's not the information, but it is added with the signal always. Okay, so where the receiver duty is to extract the signal from this noise. So we require an optimum structure, that is analog detector, for detecting the modulated sinusoid. Modulated means there is a after modulation. We can call it as modulated. Message signal can be called as modulating. After modulation, the resultant signal is called modulated signal. Okay. Another is define Costas loop. Costas loop, a carrier synchronization loop in a digital communications receiver that uses a quadrature phase detector in place of a conventional square law device. Okay, so here the Costas loop is a carrier synchronization loop. Why? Here the synchronization is very, very important in coherent detection. Why? We're having two versions of detection. One is a coherent, another is a non-coherent. Coherent means we are using the phase information or some information, some reference value, some reference signal we are considering. Then can be called as coherent. Without any reference, without any phase information, we are detecting the signal. That can be called as non-coherent. Okay, so the Costas loop is a carrier synchronization loop. Okay, another is a defined diagonal clipping. So diagonal clipping distortion that occurs in an AM demodulator where the capacitor discharge time constant is set too long for the detector to accurately follow fast changes in the AM signal envelope. Okay, so this is very important one. Here in a demodulator we are used diodes. Okay, so and some capacitors also used. So this capacitor discharge time or constant. So what do you call constant? The time constant. The time constant is RC. Some resistance value and capacitor value. It gives the time constant. So the time constant is too long. That means very long time constant. The high value of capacitor is used. High values. The capacitor is used in this circuit. It is too long for the detector to accurately follow fast changes in the AM signal envelope. So AM signal envelope having some such type of distortions coming. So this is the fast changes in the AM envelope. So it fails to follow that fast changes, having some distortion is occurred. Such type of distortion is called as diagonal clipping distortion. Coming to define modulated signal. Yeah. The resultant signal after the process of modulation is called as modulated signal. So already we discussed that one. So for modulation we require two signals. One is the message, another is the carrier. So after process of these two signals, the resultant one is come. That can be called as modulated signal. Okay. So you are done in amplitude version, that is amplitude modulated signal. If the carrier of the phase is changed according to the instance value of the message signal, that can be called as a phase modulated signal. Or the frequency of the carrier signal is varied, then it can be called as frequency modulated. Okay. So what is overmodulation? So overmodulation is the condition that prevents telecommunication when the instantaneous level of the modulated signal exceeds the value necessary to produce 100% modulation of the carrier. Here we are saying about mu. Depending on the mu, we can say overmodulation, undermodulation, or perfect modulation, or critical modulation. So for overmodulation, mu is greater than 1. If mu greater than 1, we can call it as overmodulated. Overmodulated. Define modulation index of AM. So that is mu. So mu is equal to the ratio of message signal amplitude to the carrier signal amplitude. That is AM by AC. Mu is equal to AM by AC. Okay. AM is the amplitude of the message signal. AC is the amplitude of the carrier signal. So what is need of modulation? What is need? Here we are saying two signals are required for modulation. After modulation, you can use a modulated signal. So what is the need of this modulation? Why we are doing this modulation? So baseband signals are incompatible for direct transmission. For such a signal to travel longer distance has to be increased by modulation. Okay. So here the modulation is required. Why these baseband signals are not suitable for long distance communication? So we have a simple formula, C equal to F lambda. So based on that, we can conclude the height of the antenna is much more without modulation. If you use modulation, the antenna size will be reduced. Without modulation, the antenna height may be in kilometers. After modulation, it might be in meters. Okay. So what is the use of frequency translation? Frequency translation is used to transfer the passband signal to baseband. Okay. So what is a passband and what is baseband? Baseband is nothing but original signal, original message signal. That is low frequency signal. After modulation, it is going to the passband. Okay, passband region. So the signals can be called as passband. So passband signal. Okay. So the frequency translation is used to transfer the passband to baseband. Again back. So modulation, demodulation. What is multi-tone modulation? So in modulation having two varieties, single tone, multi-tone. So first one is a multi-tone. Modulation done for the message signal with more than one frequency component is called multi-tone modulation. More than one frequency component. That can be called as multi-tone. For single frequency, it can be called as single tone. So what is VSB-SC? Vestigial sideband modulation. Vestigial sideband. So this vestigial sideband you use it for the video, the operation of video signals. Okay. So now VSB-SC modulation is defined as a modulation in which one of the sideband is partially suppressed and vestige of the other sideband is transmitted to compensate for the suppression. Why? Because we're having two sidebands. So two sidebands with the full carrier can be called as amplitude. If you carry suppression, we can call it as DSB-SC. Again, we are going to cut one of the sideband that can be called as single sideband. So the vestige here, we are going to suppress some part of that sideband, and another is send as usual. So why we are using such type of modulation? For the video signals require more bandwidth. Okay, so VSB-SC is suited for video signals. We're not sending only voice signals. Video signals also required for transmission. So such type of signals previously used VSB-SC modulation, vestigial sideband. Why video signals require more band? So we are going to cut one band that is not sufficient for SSB. Okay. What is a balanced modulator? So balanced modulator is a modulator in which the carrier and modulated signal are introduced so that the output contains the two sidebands without the carrier. Just you are going to multiply. So here you can say DSB-SC. What is the output of this balanced modulator? That is nothing but DSB-SC. It is S of t is equal to C of t into M of t. Carrier and message signal is going to multiply. We can produce the balanced modulator which produces the output of the DSB. Here the output of the balanced modulator is nothing but DSB-SC without the carrier. Okay. Define low level modulation. So low level modulation is the modulation in which modulation is done at low power level. At low power level. So the power level is very low, then we call as low level modulation. What is the DSB-FC? This is nothing but AM. DSB-FC is the modulation in which the sidebands are transmitted along with the full carrier wave. So it is another name of AM is DSB-FC. So defined as spectrum of a DSB-SC wave. So the spectrum of DSB-SC wave contains upper sideband, lower sideband without carrier. What the spectrum contains. Okay. Define bandwidth of DSB-SC wave. So bandwidth of AM signal is defined as the difference between upper sideband frequency to lower sideband. Now the bandwidth is simply 2FM. Define average power of carrier signal. The average power of the carrier signal is AC square by 2R. AC square by 2R. So average power. So that is PC is equal to AC square by 2R. Here AC is the amplitude of the carrier signal. R is the load resistance, having some value in ohms. Okay. Define envelope detector. So envelope detector, the optimum structure for detecting a modulated sinusoid with a random phase in the presence of relative wide Gaussian noise. So it is to detect the signal. Define demodulation. Recovery of message signal from modulated wave is called demodulation. So this demodulation is done at the receiver. Modulation is done at the transmitter. Okay. So what is amplitude modulation? Amplitude modulation may be defined as maximum amplitude of carrier wave is varied in accordance with the message signal amplitude. So we can say in a different ways. What that one? The amplitude of the carrier signal is varied in accordance with the instantaneous value of the message signal. So that is called as amplitude modulation. What is the CW? Continuous wave modulation. A high frequency sine wave is used as a carrier wave. Then it is called continuous wave modulation. Yeah, already this one line. So define perfect modulation. The modulation index is equal to 1. Then the modulation is called as perfect modulation. That is, my mu value is equal to 1, 100%. That is perfect modulation. Sometimes it says critical modulation. List the generation methods of SSBSC. Single sideband suppressor carrier generation methods. That is, the frequency discrimination and phase distribution methods are used to generate the SSBSC signal. One is the frequency discrimination and another is the phase discrimination methods. Define frequency mixer. So a device that performs the frequency translation of a modulated wave, that can be called as frequency mixer. So frequency translation. Already we see that frequency translation, passband to baseband, baseband to passband. So that is a frequency translation. So the device which performs such type of operations, such type of frequency translation, we can call as frequency mixer. Define carrier suppression. Carrier suppression is generally used as a method to significantly reduce the amount of unnecessary transmitted power based upon the fact that no information is contained within the carrier amplitude in an AM waveform. Here, one thing. So in AM, we have already known DSB EFC means double sideband full carrier. Already you know in modulation, carrier is a high frequency signal without any information. So the carrier is no use. It just use the carrier. It's carrier. So why sending all this full carrier? So what happens? Here it increases more power and more bandwidth. The carrier increases more bandwidth and more power. So for efficient communication, we must reduce the bandwidth and power also. So for such condition, we are going to suppress this carrier. So there is carrier suppression. Then get DSB-SC. Define coherent detection. In coherent detection, locally generated carrier is exactly coherent or synchronized in both frequency and phase with the original carrier wave CF, which is used to generate the DSB-SC or SBSC wave. SSB or DSB. So simply again, coherent detection means with synchronization. So there is no synchronization, it is non-coherent. If there is a synchronization, it is called coherent. Okay. So these are varieties of detection. So what are the degrees of modulation? So already know mu or m less than 1, m equal to 1, m greater than 1. So when m is less than 1, we can call it as under modulation. When m equal to 1, perfect modulation. When m greater than 1, over modulation. Okay. So we require the perfect one. What is a super heterodyne receiver? The super heterodyne receiver converts all incoming RF frequencies to a fixed lower frequency called intermediate frequency IF. This IF is then amplitude and detected to get the original signal. Super heterodyne receiver. Define multiplexing. So multiplexing is defined as a process of transmitting several message signals simultaneously over a single channel. By using single channel, but transmitting several message signals. So such type is called multiplexing. Okay. So in that multiplexing, we have frequency division multiplexing, time division multiplexing are there, different varieties. So what are the advantages of ring modulator? So its output is stable. It requires no external power source to activate the diodes, virtually no maintenance, and another one is a long life. So these are the advantages of ring modulator. So references. So the content of information is taken from Commissioner Salman Hacking, J.S. Titodi, Sanjay Sharma. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.